Hello again. We're going to be talking about matrices, and eventually we'll be using matrices to solve systems. If we're looking at this first 3 by 3 system, again 3 by 3 because there are 3 variables, x, y, and z, and 3 equations there. If we want to talk about the coefficient matrix, the coefficient matrix is formed by looking at the coefficients from equations 1, 2, and 3. So if we look at the first equation, there is no x, so the coefficient on x would be 0. The coefficient on y, or the number in front of y, is -3, and the coefficient on z is 2. So the first row of the coefficient matrix would be 0, -3, 2. Moving on to equation 2, now notice z is missing. So coefficients would be 2, -1, 0. And finally, the last row there, the third equation, 3, -2, 3. So a matrix is really just what we call an array of numbers. And this, because it has 3 rows and 3 columns, is called a 3 by 3 matrix, like that. When we want to talk about the constant matrix, we look at the other side of the system. And those numbers, 3, -1, 4, form the skinny matrix that would look like this. Finally, the augmented matrix represents the entire system. So we start with that coefficient matrix, 0, -3, 2, 2, -1, 0, 3, -2, 3. Then we just put up a dashed line like this to augment that with the constant matrix. And this augmented matrix represents the entire system that we see here. If we consider the next system here, this system is super easy to solve. Can you see why it's super easy to solve? Notice they already tell you what z is in that system. So if we take that z value and plug it back into the equation above it, we're then able to find y. Then once we have y and z, we can go back up to the first equation, replace y and z, and that allows us to find x. So that is what we refer to as back substitution. So let's go ahead and solve this system using back substitution. Like I said, we already know z is -1, our third coordinate. Now, replacing z in the second equation, we'll have y plus 2 times -1 is -4, or y minus 2 is -4. Adding 2, we now see that y is in fact equal to -2. So now we can come over here in our solution and replace y with -2. Now looking at the first equation, we're going to replace the y with a -2 and the z with a -1, and that allows us to solve for x. So x minus 3 times -2 plus 4 times z, -1, is 5. Well, -3 times -2 is +6. 4 times -1 is -4. So 6 plus -4 yields +2. So x plus 2 is equal to 5. Subtracting 2, we find x here is 3. And there's our solution, 3, -2, +1. If we look at the augmented matrix associated with this system, remember we want to start with the coefficient matrix first. So the coefficients on the first equation are 1, -3, 4. The second equation is missing x, so coefficients would be 0, 1, 2. The third equation is missing both x and y, so 0, 0, 1, and then we would augment that with the constants from the other side, 5, -4, -1. And the augmented matrix that you see here is in what we call, let's highlight this, reduced row echelon form. So what's important to note about reduced row echelon form is that if we look at the diagonal in the coefficient matrix, when we talk about the diagonal, we're always talking about the diagonal from left to right. Along that diagonal from left to right, straight down through the middle there, we have ones. Also, what you should notice is that if you look below that diagonal, you have zeros. So anytime you have ones along the diagonal and zeros below, you are in that reduced row echelon form. We prefer reduced row echelon form because any matrix that happens to be in reduced row echelon form, when we consider the system associated with it, we know that system is super easy to solve using back substitution. So if we look at this next matrix down here, the directions just ask us to write the system represented by the augmented matrix. I want you to notice first that matrix is in fact in reduced row echelon form. Ones along the diagonal, zeros below. I know this system would be super easy to solve using back substitution. We're not asking you to solve it here. All we're asking you to do is to work backwards to write the system that's associated with the matrix. So if you can start with the system and produce the matrix, you should also be able to look at the matrix and write out the system. So when I look at the first row, reading the first row, I know this is the coefficient with x, that's my coefficient on y, this is the coefficient on z, then I want to set it equal to the number from the other side. So first equation there would be x plus y minus 2z is equal to -4. Looking at the second equation, there are no x's, so we'll just start with y plus 3z is equal to 8. And finally, the last equation, super short, z is just 2. And at that point, you are finished with the problem. It does not ask you to solve, just wanted you to write the system represented by the matrix. Now, if you are asked to write the augmented matrix for this system, this is a larger 3x3 system. Notice this system is just 2 equations and 2 variables. Before you try to write the system, though, it would be nice if this were set up with x, y, and then number. So I would start by rearranging the first equation. In fact, to rearrange the first equation, I would add this 8x over to the left. And when you do 8x minus 2x, you get 6x. Write that 6x first, then the positive 2y. Put up your equal sign, and on the other side, you'll just have 4. The second equation, rearranging that, all you need to do is move the x over to the left. So just add x. I'm getting x plus 5y is in fact equal to 6. And now this looks just like the 2x2s that we're used to solving using elimination. Now that it's in the correct form, if you're going to write the augmented matrix, your matrix is going to be smaller than the 3x3 matrix. In fact, when you start with the coefficients, your coefficient row, you're not going to worry about having that third column for z. Just do x and y. So you'll have 6 and 2. Similarly, The coefficients on the second equation are just 1 and 5. Go ahead and augment that with the constants from the other side, 4 and 6. And you have a much smaller equation when you only, or matrix rather, when you have only a 2 by 2 system. So 2 by 2 system, augmented matrix looks like this. 3 by 3 system, augmented matrix looks like this. What we're going to do next is we're going to talk about how to take matrices, like the one we see here and the one we see here, and get them into reduced row echelon form. Again, we like reduced row echelon form because it's easy to solve using back substitution. And it turns out that we can use what we call row operations in order to transfer matrices that aren't into reduced row echelon form into matrices that are. So again, our goal is going to be to get ones along the diagonal and zeros below. And you're allowed to do some different row operations to do that. Think about what would happen in this system if I were to interchange row 1 with row 2. So here, if you swapped the two equations around, now the first row down here would read 156, and the bottom row down here would read 624. And that would still be the same exact two equations that you see here because they're just interchanged. That would be the first quote-unquote allowable row operation, interchanging two rows. We definitely wouldn't want to try to interchange two columns because that would change the equation entirely. If we saw 2x plus 6y equals 4, it wouldn't be the same system that we originally had. So we have row operations, but we do not have column operations. The second thing that we're always allowed to do is we can always multiply an entire row by a number. For example, when we're doing elimination, it would be nice to multiply this entire row by -6. And because you're multiplying everything, or both whole sides, by -6, you're not really changing that equation as well. And then finally, the last thing that we're allowed to do is replace a row with the sum of that row and the multiple of another. And that's exactly what we are doing when we are using that elimination method. So if I were to multiply the bottom by -6 and then add it to the top to make the x's go away, that is in fact the elimination method that we have been performing. So let's review the 3 allowable row operations that we just discussed. Again, the first allowable row operation is that we can always interchange two rows. The second allowable row operation is that it is okay to multiply an entire row by a non-zero number. And then finally, we can replace a row with the sum of that row and the multiple of another row. So we use these row operations to get a matrix into that reduced row echelon form. So again, I want you to remember what that reduced row echelon form looks like. Our goal with reduced row echelon form is again to have ones along the diagonal like this and zeros below. We don't care at all what any of the other numbers are. So maybe this is a -8. Maybe this is even a fraction, like 1/4 or a -1/2. And on the other side, 321, 2, and I don't know, -9. The goal here is just those ones along the diagonal and zeros below. So when you're trying to get to reduced row echelon form, it's always good to have a path to start with. Your first goal is always going to be to get the 1 in the first position. When I look at this first example, the easiest way to place a 1 in the first position would be to use that first row operation where I'm just interchanging two rows. In fact, if I swap the first row, row 1, with the second row, row 3, that would then place a 1 up here in the first position. So let's go ahead and do that. Anytime we're doing a row operation, we want to write down what it is we're doing first before we actually do the row operation. So I'm going to go ahead and interchange row 1 with row 3. So using a double-sided arrow like this tells me that you're just swapping row 1 and row 3. And now I'm going to go ahead and do that. So now my top row will read 1, 2, 4, and on the other side 1. My bottom row will read 2, 2, 7, 3, and my middle row hasn't changed at all. 3, 6, 8, and -1, like this. Okay, after you have a 1 in the first position, the next step is to go ahead and get the zeros below it. Those zeros down here, those 2. In fact, if I want to change this 3 into a 0, we're going to use the third row operation, where we replace a row with the sum of that row and the multiple of another row. If I'm looking at the 3 in the second row and I want it to become a 0, then I would like up here in the first row to have a -3. So I'm going to do -3 times row 1, but after I've done that, I want to go ahead and add that to row 2. So I'm going to write out what I'm doing first. I'm going to do -3 times row 1, and then I'm going to add that to row 2, like this. If I run through and multiply row 1 by -3, I'm just going to go ahead and write above it up here what would happen. So multiplying row 1 by -3, 1 times that -3 yields a -3. 2 times -3 gives -6. 4 times -3, -12. And finally, 1 times -3 is in fact -3. Over here, my new matrix, the first row with the 1 in it is not going to change. So I'm going to start by copying the first row exactly as it is. 1, 2, 4, 1. Now the second row, this is where I want my 0. I'm going to take that new red row right there, that where we multiplied row 1 by -3, and I'm going to add that with row 2. Then when I add -3 plus 3, I get a 0 where I want it. Continuing to add, -6 plus 6 is also 0. -12 plus 8, -4. -3 plus -1, -4. In this same step, we can also get a 0 down here if we look at row 3. Here I have a 2. Looking up top here, it would be nice if instead of a 1, that were a -2. Then when I do -2 and +2, I would get a 0 in that position there. So again, I'm going to look at row 1, the top row, but this time, because I'm looking down here at row 3, and I want a -2, I'm going to multiply -2 times row 1, and I'm going to add that to row 3. So writing out first what I'm doing before I do it. Okay, now looking up at the top row and multiplying everything by -2, I'm just going to write down here what would happen. So I'm doing this 1 times -2 to get -2. 2 times -2, -4. 4 times -2, -8. And finally 1 times -2 is in fact -2. And remember, your goal was to get a 0 here. So now add that bottom row with that new row 1 to produce a 0 in this position. 2 plus -2 is 0. 2 plus -4, -2. 7 plus -8, -1. 3 plus -2, +1. Okay, so again, first step, 1 in the first position, then the zeros below. The next step is actually to get the 1 in the middle that you see here. And if I look at my middle number right now, I see a 0. It's almost impossible to take a 0 and change it into a number 1. So it would be better at this point if I first interchange row 2 with row 3. And also I want you to notice that swapping those two rows around would give me some more zeros that I'm also looking for. So at this point, I would now interchange row 2 with row 3. And we're going to copy the entire matrix at this point. So the only row that's not changing is, again, that first row. 1, 2, 4, 1. Okay, swapping row 2 with row 3, my new row 2 is 0, -2, -1, +1, and new row 3 becomes 0, 0, -4, -4, like this. Okay, now if I'm trying to make this number a 1 in the middle, the easiest way to do this is actually to multiply an entire row by a non-zero number. So I'm going to use row operation 2 that we haven't used yet. In fact, -2 times what would change this to the number 1? Well, if you multiply -2 times -1/2, -2 times -1/2 would yield 1. So this time we're going to go ahead and multiply all of row 2 by a -1/2. So I'm just going to write down what we're doing first, -1/2 times row 2, and then I'm going to move my work down here since we're out of room. This time we are not changing the top row, nor are we changing the bottom row. Only thing we're doing is focusing on getting that 1 in the middle, and the only row that's going to change is row 2. So I'm going to copy row 1 again, exactly as it is. 1, 2, 4, and 1. In the middle, 0 times -1/2, 0. -2 times -1/2, +1. And that's that 1 that we were looking for. Remember to multiply the entire row though. So -1 times -1/2 is a 1/2. And 1 times -1/2 would give us a -1/2, like this. For now, I'm just going to copy that third row exactly as it is. 0, 0, -4, -4. Okay, so first step, 1 in the first position, 0's below. Next step, 1 in the middle. After that, your next step is to get a 0 below. And I want you to notice in this problem, this is a little bit easier because we already have that 0 below right there. The very, very last step is to now get your 1 in this position. And you can do something similar to what we just did in the last step to change that -4 to a 1. So again, I'm using row operation 2 where I'm going to multiply an entire row by a non-zero number. What number can you multiply -4 by if you want it to become +1? If you're thinking -1/4, you are correct. So the last step is going to be to multiply -1/4 times row 3, like this, giving us the 1 in the last position. So row 1 will remain the same. Row 2 also remains the same. And finally, multiplying all of row 3 by -1/4, 0 times -1/4 is still 0. We'll do that twice. And -4 times -1/4 is the 1 we were looking for. This -4 times -1/4 also gives us a 1 here. And I want you to notice we have produced reduced row echelon form. 1's along the diagonal, 0's below. And for now, we're not going to worry about solving. We're just going to worry about getting this into reduced row echelon form. Let's go ahead and try another one here. This one's a little bit more difficult because there's not an easy swap of two rows that will start us off with 1 in the first position. So remember in the last example, we could just interchange row 1 and row 2. So a couple of different ways you could get a 1 in the first position. If you were to multiply row 1 by 1/5, 5 times 1/5 would give you a 1 in the first position. But I want you to notice that when you multiply everything by 1/5, you would have a 1/5 here, a negative 2/5 here, and a 4/5 here. And you would give yourself fractions right away. If you look at the 3 rows here, which row would you be able to multiply by a number and not get fractions? If you're thinking about row 2, that would be correct. See, if I multiply row 2 by a negative 1/2, that would give me a 1 right here. 4 times negative 1/2, though, is in fact negative 2, not a fraction. I would get another negative 2, and then 6 times negative 1/2, negative 3, also not a fraction. So the best way to get a 1 in the first position would actually be to multiply row 2 by a negative 1/2. And then swap it with row 1. And that would give us a 1 up here in the first position that we want. So let's go ahead and do that now. So multiplying row 2 by negative 1/2 and then moving it up to the first row. Negative 2 times negative 1/2, the 1 we wanted. 4 times negative 1/2, negative 2. Another 4 times negative 1/2. And finally 6 times negative 1/2, negative 3. Okay, because I moved row 2 up to row 1, that row 1 now needs to go in row 2 because we made a swap. So copy it exactly as it is. 5, 1, negative 2, 4, and copy your third row. 3, 5, 2, and 10. Next step is to go ahead and get the zeros below it. So always a 1 in the first position, then the zeros below. Because I have a 5 here, it would be nice if this were a negative 5. So we're going to do negative 5 times row 1, and we'll run through and add that to row 2. So I like to switch colors when I do that. Multiplying the top by negative 5, I'm just going to write above it what I would get. 1 times negative 5, negative 5. Negative 2 times negative 5, 10. Negative 2 times negative 5, another 10. And negative 3 times negative 5, 15. Okay. I am not changing the top row that has the 1 that I want. So first thing I'm going to do is just copy the top row exactly as it is. All right, now adding row 2 to that new row 1 that we just wrote out here up in red. Negative 5 plus 5, the 0 we wanted. 10 plus 1, 11. 10 plus negative 2, 8. And 15 plus 4 gives 19. Okay, now we want a 0 down here. So looking at row 3, because this is a positive 3, I want this to become a negative 3. So now I need to do negative 3 times row 1 and add that to row 3 to get the 0 in that bottom position. Grabbing my red pen again, I'm going to write down here what happens when I multiply the first row up here by negative 3. Negative 3 times 1, negative 3. Negative 3 times negative 2, we'll get 2 6s there. And negative 3 times negative 3, 9. Adding that with row 3, 3 plus negative 3, 0. 5 plus 6, 11. 2 plus 6, 8. And 10 plus 9 gives 19. Okay, so again, remember your roadmap. 1 in the first position, 0's below. Next step is the 1 in the middle. When you're trying to get the 1 in the middle, you want to think about what number you could multiply 11 by to change it to the number 1. So think fractions here. 11 times what is 1? Well, 11 times 1/11 would yield 1. So I'm going to do 1/11 times row 2, and that will give me a 1 in the middle position. This time, my first row is remaining the same, and my middle row will be changing, but my bottom row is also remaining the same. All we're worried about right now is the 1 in that position. Multiplying that entire row 2 by 1/11. 0 times anything, 0. 11 times 1/11, there's the 1 I was looking for. If you do think of 8 as a fraction, it's like 8 over 1. So if you're multiplying 8 over 1 times 1 over 11, you don't need your calculator. Just multiply the tops, multiply the bottoms, straight across. 8 times 1 is 8, and 1 times 11 is 11. Same thing when you do 19. Think 19 over 1, multiply straight across, and you'll get the fraction 19/11. Okay, so we have the 1 in the first position, 0's below. We have the 1 here. Remember, the next step is the 0 below it. Because this is an 11, it would be nice if this were a negative 11. So now we want to multiply negative 11 times row 2. And we're going to go ahead and add that to row 3 to get the 0 below that 1. So this time, row 1 and row 2 are both finished. So in the next step, I'm going to copy row 1 exactly as it is. I'm also going to copy row 2 exactly as it is. Okay, multiplying row 2 now by a negative 11. 0 times negative 11, 0. 1 times negative 11, negative 11. 8 11ths times a negative 11. Well, a positive times a negative is a negative, and that works out nicely because this 11 is on bottom and this 11 is on top, so that fraction clears and we're just left with a negative 8. Same thing here, 19 11ths times negative 11, clear the fraction, and you're just left with a negative 19. And this time, when you go to add that negative 11 times row 2, that new red row you produced, with the original row 3, 0 plus 0 is 0. 11 plus negative 11, that was the 0 that you were looking for. 8 plus negative 8, 0, and 19 plus that negative 19 is 0. The very, very last step here would be to make that 0 a 1, but as we discussed before, you cannot change a 0 into a 1. So if they were asking you to take this and get reduced row echelon form, you couldn't get all the way to reduced row echelon form. This is as close as you possibly could get though. So you would just stop here. All right, so this is the point where you might want to consider trying the next problem on your own and pausing the video again. Let me give you a hint on how I would go about starting this before you hit the pause button. I would look at row 2 because that's the only row that's not going to give me a fraction. And remember, our goal is first to get a 1 in the first position. So if I was trying to get a 1 in the first position, I would start this problem by doing 1/2 times row 2, and then remember we want the 1 up here, so I would interchange that with row 1. So go ahead and hit pause now and try that on your own. Once you're finished, start the video again to see my solution. Okay, So we're starting by multiplying row 2 by 1/2. So 2 times 1/2 is 1. And I'm writing down what I get up here in the first row because, again, we're swapping row 1 with row 2. 2 times 1/2 again, another 1. 4 times 1/2 gives me a 2. And that 6 times 1/2 would give me a 3. Okay, the old row 1 is now going to be row 2. So I'm just going to copy that exactly as it is. -2, 1, -1, 3. And I'm leaving row 3 alone. 3, 1, -1, 2. All right, after we have a 1 in the first position, next step is the zeros below it. So to get a 0 here, because that's a -2, it would be nice if this were a +2. So hopefully you did 2 times row 1 and added that to row 2. Similarly, because this is a 3, it would be nice if this were a -3. So now I want -3 times row 1, adding that to row 3. Okay, multiplying row 1 by 2. I'm going to write up here what I get. 2, 2, 4, and 6. And remember, we're adding that to row 2. So when I go to write the new matrix, leave the first row alone. 1, 1, 2, 3. Now, new red row gets added to the middle row to give the 0 we're looking for. 2 plus -2, 0. 2 plus 1, 3. 4 plus -1, 3. 6 plus 3, 9. Okay, we said we're also going to multiply the top row by a -3 to get a 0 down here. So switching pens again, we're going to multiply row 1 now by -3. So I'm getting a -3, another -3, 2 times that -3, -6, 3 times that -3, -9. Okay, adding that to the bottom row, 3 plus -3, 0. 1 plus -3, -2, -1 plus -6, -7, 2 plus -9, -7. Okay, continuing. Next step is to get a 1 in the middle. And I want you to notice that if you were to multiply 3 times 1/3, you would get a 1 in that middle position. And that 1, creating that 1 rather, or multiplying by that 1/3 doesn't even yield fraction. So I would definitely just start multiplying 1/3 times row 2 to get the 1 in the middle that we're looking for. Top row doesn't change. Middle row, 0, 1, 1, 9 times 1/3, 3. And then leave the bottom row alone. 0, -2, -7, -7. All right, next step was to go ahead and get a 0 below it. So when I look below it at this -2, it would have been nice if that were a +2. So let's write out what we're going to do first. We're going to do 2 times row 2 to make that a +2. Then when we add it with row 3, that will give us the 0 that we're looking for. So 2 times row 2 added to row 3. The rows that aren't changing are row 1 and row 2. So I'm going to quickly copy those exactly as they are. And now I'm going to go ahead and multiply that row 2 by 2. So I'll just write down here what I get since I'm going to be adding it with row 3. 0 times 2, 0. 1 times 2, 2. 1 times 2, 2. 3 times 2, 6. Add those two rows together to get your new third row. 0 plus 0, 0. Negative 2 plus 2, 0. Negative 7 plus 2, negative 5. Negative 7 plus 6, negative 1. Last step is finally to make that number a 1. So again, you want to think negative 5 times what will give you 1, and think fractions. Negative 1/5 times negative 5 would yield a positive 1. So to finish, we just want to do negative 1/5 times row 3. So first row remains the same. Second row remains the same. And finally, when I multiply 0 times anything, I get 0. So I'll have a 0, a 0. And now when I do negative 1/5 times negative 5, that's the 1 we were looking for. And then don't forget to do negative 1 times that negative 1/5 as well to give a positive 1/5. And now we are in reduced row echelon form. Notice 1's along the diagonal, 0's below. The next problem is a little bit different, and it's different because now the directions tell you to solve. So up here, we weren't trying to solve, we were just trying to get things into reduced row echelon form. Now they want us to solve the system. So let's talk about how we're going to attempt to do this. If we're solving systems using matrices, that's what's called Gaussian elimination. So if on a test or a quiz, they ask you to use Gaussian elimination, this is the method that they're asking you to solve that system using, okay? So what we're going to do is we're going to write the system, the matrix, the augmented matrix associated with the system first. This augmented matrix will not be in reduced row echelon form. Then we're going to use row operations to take that matrix and get it into reduced row echelon form. Once we have reduced row echelon form, we'll write out the new system, which will then be super easy to solve using back substitution. Let's try it. So start first with the augmented matrix. This is only a 2 by 2, so this is going to be much, much easier and much, much smaller. So coefficient matrix, 5, 2, 2, 3. Augment that with the constants from the other side, 3, negative 1. Okay, now if you're going for reduced row echelon form, this is going to be a lot smaller than the one we just did here, but the first step is going to be to get a 1 in that first position. After you've done that, we'll get the 0 below, and then after we've done that, we just need a 1 here to finish. So start out by getting a 1 in the first position. I can't avoid fractions. Either multiply the top by 1/5 to give a 1, or I could multiply the bottom by 1/2 to get a 1 here and then swap it, but either way, I'm stuck with fractions. So I personally would just do 1/5 times row 1, even though we'll be dealing with fractions now. So 5 times 1/5, there's the 1 that we wanted. 2 times 1/5, 2 over 1 times 1/5, straight across, 2/5. 3 times 1/5, 3/5. Leave the bottom row alone, 2, 3, negative 1. Okay, next step is to get the 0 below it. Because this is a 2, it would be nice if this were a negative 2. So I want to do negative 2 times row 1 and then add that to row 2. Keep in mind when I'm doing this, I don't really want to change the top row. So I'm just going to copy my top row first so that I don't change that. I want to keep the 1 in the first position. All right, now multiplying the top row by a negative 2. Negative 2 times 1, negative 2. Fractions. You don't need your calculators. 2/5 times negative 2. Think of that as negative 2 over 1. 2 times negative 2, negative 4 on top, 5 times 1, 5 on bottom. Same thing here. Think of it as negative 2 over 1 and just multiply straight across. Top, negative 6, bottom, 5. Okay, I'm going to add this to the bottom row. That negative 2 plus 2 gives me the 0 I was looking for. Okay, when I'm adding negative 4/5 plus 3, I'm thinking of this as 3 over 1. And remember, when you're adding fractions, you need a common denominator. So because there's a 5 here and a 1 here, the common denominator is in fact 5. You can use your calculator. I personally don't recommend it. I would just think if I were to multiply 3 over 1 by 5 over 5, I would think of that as being 3 times 5 is 15 on top, 1 times 5 is 5 on bottom. So that's a 15/5 and a negative 4/5. Now that I have the common denominator, 15/5 plus negative 4/5, 11/5. Same thing here. If I put this over 1, the common denominator would be 5. So this is like negative 5 over 5, and this is a negative 6 over 5, which is a negative 11 over 5, like that. And you can always pause and punch it into a calculator at this point so you can see it, or write out all the steps if you need to, but getting a common denominator to add the fractions together. Okay, next step, or last step for reduced row echelon, is to get a 1 in this position. So 11/5 times what would give the number 1? Well, the reciprocal, 5/11. So we're going to do 5/11 times row 2, and that'll give me a 1 in that position. Top row stays the same. 1, 2/5, 3/5. Bottom row, 0, 11/5 times 5/11. 1. Negative 11/5 times 5/11. Well, negative 1. Now that we're in reduced row echelon form, let's write the new system associated with that matrix. So remember, the first column was x, the second column was y. This is the constant from the other side. So my new first equation just reads x plus 2/5 y equals 3/5. My new second equation doesn't have an x. It just says y is negative 1. And now this system here is super easy to solve using back substitution. In fact, if I'm going to write my answer over here as a point, I already know from the second equation that the y coordinate here is negative 1. Now I'm just going to back substitute that negative 1 in for y in the first equation. And it'll say x plus 2/5 times negative 1 is 3/5. Multiply first. 2/5 times negative 1 is negative 2/5. So x minus 2/5 is equal to 3/5. And if you're trying to solve for x, you're just adding 2/5 here. And at least you have a common denominator already. X will be equal to, well, 3/5 plus 2/5 is 5/5. But 5 over 5 is really just 1. So x there is 1. So again, to solve using Gaussian elimination, what we want to do first is write the matrix, the augmented matrix associated with the system. Then we use row operations following that roadmap where we put a 1 in the first position, then get a 0 below, and finally get our 1 here. After we have reduced row echelon form, the new system we can solve quickly using back substitution. Let's go ahead and try another 2x2 before we move on to 3x3s. So again, first step, write the matrix associated with the system. super quick and easy. Augmented matrix, -1, 3, 5, -2, augmented with the constants, -7 and -4. Looks like this. This one is a little bit easier. If I want a 1 in the first position, all I have to do is multiply that first row by -1. And you can even just write negative row 1. That will give me a 1 in the first position. -1 times -1, 1. 3 times -1, -3. -7 times -1 makes that a 7. Okay, second row doesn't change. Next step is to make this 5 the 0. So 1 in the first position, then zeros below. So if I want this 5 to be a 0, then it would be nice if this 1 were a -5. So I want to do -5 times row 1, and then we'll go ahead and add that to row 2. This time, the first row is not going to change. Looks like this. Okay, if we were to multiply the first row by -5, let's write it down here this time since we're going to add those two together. 1 times -5, -5. -3 times -5, 15. 7 times -5, -35. And now we're going to go ahead and add 5 plus -5, 0. -2 plus 15, 13. -4 plus -35, -39. Looks like this. All right, last step is to now get a 1 in this position. And I see a mistake. Okay, so let's fix this first. Let's come back here. See how this was a -7? We want to make sure that this is also, no, we multiplied by -1. That's right, a +7. Hold on. Maybe we don't have a mistake at all. This one's just going to be a lot easier. So finally, looking to get a 1 in this position, we just want to go ahead and multiply row 2 by what number? So again, think 13 times what would give me 1? 1/13. So we're going to do 1/13 times row 2. So top row stays the same. 1, -3, 7. Bottom row, 0, 13 times 1/13, 1, -39 times 1/13. If you think about taking out 13s, you're going to get a -3 there. Now if we look at the system associated with this, the new system would be x minus 3y equals 7. And the bottom one would just say y is -3. All right, writing our solution as a point, the y coordinate is -3. Now I'm going to come back and replace that y with a -3 in order to solve for x. X minus 3 times -3 is 7, or x plus 9 equals 7. Subtracting 9, you'll find x is in fact -2. Answer looks like this. That one was probably easy enough. You could have done it yourself. It might be a good time to hit pause, maybe go back and try it and see if you get the same solution as well. All right, on to the big boys, 3x3s. We're going to do the same thing. We are going to start by first writing the augmented matrix associated with the system. Then we're going to reduce row echelon form. Not yet. Write the augmented matrix, then use row operations to get into the reduced row echelon form. Once you have the reduced row echelon form, write the new matrix, new system, then solve that system using back substitution. This one's going to be a little bit ugly. Just giving you guys a heads up ahead of time here. But let's dig into it, see what happens. Okay, so looking up at the coefficients first. Coefficient matrix, 2, -3, 2, 3, -4, -3, 3, 1, -1. We're going to go ahead and augment that with the constants, 13, 1, and 2. Okay. Again, no way to avoid fractions. So I'm just going to go ahead and start with 1/2 times row 1 because I'm trying to get a 1 in that first position. So 1/2 times row 1. 2 times 1/2, 1. -3 times 1/2. Multiply -3 over 1 times 1 over 2 straight across to get -3 over 2. 2 times 1/2, 1. And 13 over 1 times 1 over 2 is 13 over 2. Okay, the bottom two rows I'm going to leave alone. 3, -4, -3, 1, 3, 1, -1, 2. After you have the 1 in the first position, now zeros below. So to get those zeros below, at least we want that number to be -3 for both of these. So let's go ahead and just write out what we're going to do. We're going to do -3 times row 1, and then we'll add it to row 2. We're also going to do -3 times row 1 and add that to row 3. So the first step will produce a 0 here. The second step will produce a 0 here. We do not want to change the 1 that we already have. So copy the first row with its fractions exactly as it is. Looks like this. Okay, now let's go ahead and multiply that first row by -3, and let's just write down here what we would get. 1 times -3, -3. Okay, -3 over 2 times -3 over 1. If you multiply straight across, -3 times -3, 9 on top. 2 times 1 on bottom, 2 on bottom. 1 times -3, another -3. And finally, I want 13 over 2 times -3 over 1. So top, 13 times -3, -39. Bottom, 2 times 1 is 2. Okay, adding that to row 2. This -3 and this +3 is my first 0 I wanted. Okay, -4, and if you think about 9.5 as a mixed number, that's 4.5. So if I had -4 plus 4 1/2, that's just 1/2. Or get a common denominator, -8 over 2 plus 9 over 2, also positive 1/2. -3 plus -3, -6. And then this 1 over 1, because I need a common denominator, is really a 2 over 2. So 2 over 2 plus -39 over 2, -37 over 2. And again, if you're struggling with the fractions, hit pause at any time. Feel free to use your calculators or just come off to the side with some scrap paper getting those common denominators. -3 here plus this 3, the other 0 we were looking for. All right, 9/2 plus 1. Think of that 1 over 1 as 2 over 2. So 2 over 2 plus 9 over 2, 11 over 2. -1 plus -3, -4. Okay, 2 over 1 plus -39 over 2. Common denominator is 2. So that 2 over 1 is really a 4 over 2 plus a negative 39 over 2. I'm getting a negative 35 over 2. Okay. 1 in the first position, 0 is below. Next step is to make this a 1. So 1/2 times what is 1? Well, 1/2 times 2 would give me 1. So now I'm going to do 2 times row 2. Notice multiplying that whole row 2 by 2 is kind of nice because we're going to lose that fraction. That's going to become the one we want, but we'll also lose this fraction as well. So things are working out nicely for us here. Top row stays the same. Bottom row also stays the same. Middle row, multiply everything by 2. 0 times 2, 0. 1/2 times 2, the one we wanted in the middle. Negative 6 times 2, negative 12. Negative 37 over 2 times 2, negative 37. And that fraction's at least gone. Next step is going to involve fractions again. We're going to try to get a 0 down here below it because that's an 11 over 2. I want this to be a negative 11 over 2. So I actually need to do negative 11 over 2 times row 2, and then I'm going to add that to row 3 to give me the 0 here. So the two rows that aren't going to change right now are row 1, like this, and row 2, like this. Okay, now multiplying row 2 by negative 11 over 2, let's write down here what we would get. 0 times negative 11 over 2, 0. 1 times negative 11 over 2, negative 11 over 2. Okay, negative 12 times negative 11 over 2. A negative times a negative is a positive. You could think about taking out 2's. That would become a 6, and 6 times 11 is 66. Or calculator time. If you do negative 12 times negative 11 over 2, on your calculator, sure enough, there's the 66. I'm also going to do negative 37 over 1 times negative 11 over 2. That one, nothing's going to cancel out, so to speak, and make things nice, but I need to know 37 times 11, so I'm going to use my calculator for that as well. 37 times 11, 407 on top, 1 times 2, 2 on bottom. So 407 over 2. Okay, adding those rows together. 0 plus 0, 0. 11 over 2 and a negative 11 over 2, another 0. Negative 4 plus 66, 62. And at least we have a common denominator here of 2. So on my calculator, 407 minus 35 is 372. And then on bottom I'd have 2. So that's 372 divided by 2, which works out nicely to give 186. Last step, if we want a 1 here, think about what we would multiply row 3 by. If you're thinking 1 over 62, you are correct. 1 over 62 times row 3 will give us that final 1. So, first row, copied exactly as it is. Second row, also copied exactly as it is. Last row, 0, 0, 62 times the fraction gives 1. 1 over 62 times 86, because 62 goes into 186, you're going to just get 3, or use your calculator to look at 186 times 1 over 162, and your calculator, whoops, not 162, 186 times 1 over just 62 gives that 3 that we just discussed. looks like this. Okay, now that we have reduced row echelon, next step is to consider the new system associated with that. So first equation, x minus 3/2 y plus z is equal to 13 over 2. Second equation, y minus 12z is equal to negative 37. Last equation, z equals 3. Okay, if we're going to write our answer, we're going to have a triple ordered pair, x first, then y, then z. We already know z is in fact 3. Back substitution, we're going to go back up to equation 2. If I replace that z with a 3, 12 times 3 is 36. So that would say y minus 36 equals negative 37. And if we add 36 to both sides, you can see that y is negative 1 right there. Last step, when you're looking for x, replace this y with a negative 1 and replace this z with your 3. Let's write out what we get. X, now if I do negative 3/2 times that negative 1, that's going to make that a positive 3/2, plus, instead of z, plug in your 3, and on the other side you'll have 13 over 2. And I'm going to solve this equation a little bit differently. What I would do first, because these both have a common denominator, is I would probably just subtract that 3 over 2 from both whole sides. Now the left would still have an x plus 3, but this side, 13 over 2 minus 3 over 2 is 10 over 2, which is in fact just 5. 10 divided by 2 is 5. Now, easy, subtract 3 and you'll find x is 2. Solution looks like this. Yay. So one more problem. If you're feeling good and confident, hit pause, see if you can try it on your own. This one is a lot easier than the one we just did. So if you followed everything that just happened here, I don't see any reason why you shouldn't be able to do this one here. Go ahead and hit pause, and then when you're finished, resume and see if your solution matches. Keep in mind, sometimes things are a little bit different the way you solve, but if you're coming up with the same solution, your method's probably working as well. Okay, go ahead and hit pause and see if you can do the next one. All right, back here with you. Let's start with the augmented matrix. 1, negative 3, 1, 2, negative 5, negative 3, 1, 4, 1. We're going to go ahead and augment that with the constants 8, 2, and 1. Notice we already have our 1 in the first position. Next step, remember, is to get the zeros below it. So because the 1 is here, I'm focusing on the zeros below next. Because this is a 2, it'd be nice if this were a negative 2. So I'm going to do negative 2 times row 1, and I'm going to add that to row 2. Because this is a 1, it would be nice if this was a negative 1. So I'm also going to do negative row 1, but that one's getting added to row 3. The only row that's not changing this time is that top row. Copy the top row first. 1, negative 3, 1, 8. Okay, now multiplying row 1 by negative 2. Let's write above it. 1 times negative 2, negative 2. Negative 3 times negative 2, 6. 1 times negative 2, negative 2. 8 times negative 2, negative 16. Go ahead and add that to the middle row. Negative 2 plus 2, the 0 we wanted. 6 plus negative 5, 1. Negative 2 plus negative 3, negative 5. Negative 16 plus 2, negative 14. Okay, we also need a 0 here. We said we were going to multiply row 1 by negative 1. So multiplying row 1 by negative 1, the signs would change. I'm getting -1, +3, -1, -8. I'm going to go ahead now and add that to the bottom row. 1 plus -1, 0. 4 plus 3, 7. 1 plus another -1, 0. 1 plus -8, -7. Looks like this. Okay, so first step was the 1 here, 0's below. Next step, 1 in the middle. Notice you already have that 1 as well. So remember, your next step is now to make that 7 a 0. So it'd be nice if the number above it was a -7. So to do that, -7 times row 2 added to row 3. This time, row 1 remains the same, and row 2 also remains the same. The only thing that's changing is row 3. So multiplying row 2 by -7. 0 times -7, 0. 1 times -7, -7. -5 times -7, 35. -14 times -7. I think it's 98, but let's check. Yep, 98. Okay, now adding those two rows together, 0 plus 0, 0. 7 plus -7, the 0 we wanted. 0 plus 35, 35. And -7 plus 98 gives 91. Last step for reduced row echelon is to change that 35 to the number 1. Changing 35 to the number 1 would require multiplying row 3 by 1/35. So we're going to go ahead and do 1/35 now times row 3. This time the top two rows remain the same. 1, -3, 1, 8. 0, 1, -5, -14, 0, 0, 35 times 1/35, the one we wanted. And now let's think about 91 times 1/35. It would be 91 over 35, but I think that fraction reduces. So if you want, you can even do 91 times 1/35 like this. And then remember how to change that to a fraction on your calculator. You want to hit your math button, and the first command there is going to go ahead and switch that to a fraction. And it's going to give you the reduced fraction there of 13 over 5. So always reduce your fractions if they can be reduced. Okay, once you're in reduced row echelon form, the new system associated with that would be x minus 3y plus z is 8. Y minus 5z is -14. And finally, z is 13 over 5. Okay, writing the solution right now, as always, we always know the last coordinate, 13/5. Back substitution. When I plug 13/5 in right here for z, that works out nicely because if I do 5 times 13/5, the 5's go away and it just becomes a 13. So that would actually just say y minus 13 is equal to -14. Then when I add 13, y is -1, like this. Last step, let's go ahead and find x. X minus 3 times y. Well, if we multiply that -3 times that -1, we're going to get a +3. Plus z, our z was 13/5, and that will be equal to 8, like this. If we want to add these two together, we need that common denominator. So I would think of this as 3 over 1. So if we were to multiply by 5 over 5, that's 15/5 plus 13/5. That's a 28/5. So x plus 28/5 is equal to 8. And now if we want to find x, just do 8 minus 28/5 on your calculator. Just remember that I want fraction answers, so go ahead and change that to a fraction. X then would be 12/5. And our solution looks like this.